Hello, Algebra 2 scholars. This is Mr. Bear, and I will be talking to you about systems of equations as they are graphed. So, starting with understanding systems, the first thing we need to know is that a solution is a location or locations where two or more graphs intersect. We write our solutions as ordered pairs. So remember the notation we would use. We would use x comma y with parentheses around them. So looking at these two examples, let's determine what the solution or solutions are to the system. If I look at this first one, I have a line intersecting with a parabola in two locations. So we're going to have two solutions for this one. So I'm going to write the ordered pair for each one of these solutions. Okay. So looking at the first one, I see the x-coordinate. So remember, x goes horizontally. My x-coordinate here is -4. And my y-coordinate appears to be +5. So that's one of our solutions, -4, 5. And for the other one, our x-coordinate, we didn't move left or right, so 0 is the x-coordinate. The y-coordinate looks to be -3. So those are our two solutions. For the next one, we just see two lines that intersect in one spot, and so we're going to have one solution, and that ordered pair is -6, 1. So remember, when you're finding solutions from graphs, all you have to do is look for where they intersect. All right, so pause the video, see if you can identify these, and then when you have your answers, unpause and check them. Did you come up with these answers? If so, great job. If not, please review. The next thing that you'll need to know how to do is to write an equation in slope-intercept form. So let's remind ourselves what that looks like. You should remember that that looks like y equals mx plus b. And from this, the m value represents the slope of the line. The b value represents the y-intercept. That's why we call it slope-intercept form. How do we how do we graph a line that is not in this form? Well, notice that in this equation, the variable y is by itself. Apparently, I can't highlight that, so I will instead circle it. That variable y is by itself, so what we're going to do is we're going to solve our equation for y. So you want to get the y variable by itself. So what I'd recommend that you do on each of these is start by circling where the y is. And I like, if it has a coefficient, circle the coefficient with it. Okay, so on the first one here, in order to do this, I see I have to remove some parentheses. If you notice in our slope-intercept form, there is no parentheses. So let's distribute. This will give me 1/2 x plus, what's 1/2 of 4? 1/2 of 8. 1/2 of 8 is 4. Sorry, I gave away the answer. So we have y minus 3 equals this. Remember, we're still trying to get y by itself though, so I have to undo -3, so I'm going to be adding 3 to both sides. Well, what do I add this 3 to on the other side? Well, I have to add it to the like term, so it's going to be the 4. So my inverses cancel, y equals 1/2 x plus 7. And now from this equation, we see the slope is 1/2, so rise 1, run 2, and the y-intercept is at 7. Okay, let's try another one. For this one, I have to first remove that x. I'm going to pretend that's a 1x because it is. So I'm going to take away 1x to be its inverse. The 1x's cancel out, so I bring down my -4y. Now when I write the right-hand side, notice in slope-intercept form, the x part comes first, and then the number by itself goes second. So when I look here, I'm going to write the -1x because that has the x, and then -12. Okay, that's our first step. We still have a coefficient in front of the y. Anytime there's a number in front of a y, you have to undo it with division. So we're going to divide everything by -4. Negatives cancel as well, so y equals, these negatives will also cancel, so we get the fraction 1/4 x, and these negatives cancel to make a positive. 12 divided by 4 is 3. So now we have the equation y equals 1/4 x plus 3. Okay, the next one, see if you could pause the video and model the same steps that I did from part B. Did you get this right? If you did, excellent job. If not, please review. Okay, so now let's talk about graphing linear equations. To graph a line, we first plot the y-intercept. Well, when we're looking at y equals mx plus b, that's the b value. That's the y-intercept. Then we use the slope to find other points on the graph. Remember, your slope, sometimes it's written as a fraction. Think of rise over run. So let's model a couple examples. Well, first of all, we have to solve each of these for y. So on part A, there's no parentheses, so I don't have to distribute, but I do have to add 4 to both sides. So I get y equals -3x plus 11. Terrible example because plus 11 can't be plotted on here. I tell you what, I'm going to modify this problem real quick. Let's pretend that the original problem said y plus 4 instead of y minus 4, okay? Let's pretend that had happened, because then I could subtract 4 on both sides, and we're good. So y equals -3x plus 3. Okay, so my first step is to plot the y-intercept, so that's +3. Y-intercept is on the y-axis, so I'm going to plot a dot right here. And for my slope, I need a rise and a run. So what can I divide -3 by so that I keep it as a -3? Well, that would be a 1. Since my rise is -3, I'm going to go down 3, and then my run is +1, so right 1. I can do this process again if I wanted. And then we just connect with the smooth line. Okay. Let's try the next one. This one we have to solve for y. So I need to get rid of the 3x by subtracting 3x on both sides first. So I get -5y equals -3x minus 20. So then we're going to divide everything by -5. -3 over -5, those negatives become positive, but the fraction will remain. -20 divided by -5 becomes +4. So I'm going to plot the +4. Now on this, my slope is 3 over 5. If I try to rise 3, I'm going to run off the graph. So remember when we originally had -3 over -5? You can still have that when you're graphing. So I'm going to go down 3 and left 5. Okay, and that makes a nice line over here. Okay, and that's how we're going to graph lines. So now we can graph a system. To graph a system, you just graph both lines on the same grid. So y equals -3x plus 2. I plot the +2. My slope is -3. I put that over 1, so I have a rise and a run. And there we go. I'll do the next one in a different color. Y equals 2x minus 3. I plot the -3. I need a rise and a run, so I go up 2 over 1. And you can see we have an intersection point here at 1, -1. Beautiful. For the second one, I have to solve both equations for y first. So I'll do the first one up here. So 2x minus y equals -4. So I'm going to subtract 2x on both sides. Negative y equals -2x minus 4. Think of that as a -1 in front of that. So we're going to divide everything by -1. And we end up with the equation, I wrote a little too big here, so y equals 2x plus 4. So I'm going to plot my plus 4. Slope will be 2 over 1. I can't rise 2 and run 1, so I'll go down 2 and left 1. All right, now for the next one, I'm going to do that in green. I'm going to subtract x on both sides, and I get -y equals -x minus 1. That's a -1 in front of the y, so we're going to divide everything by -1. Y equals positive x plus 1. So I go up to plus 1, I rise 1, run 1. I can also go down 1, left 1. And just be really careful here. These lines intersect actually at this point here that I did not draw that very well. That intersection point is -3, -2. Okay? Good news is you'll do a lot of this on Delta Math, but you will need to know how to do it by hand for an assessment. What happens if two lines do not intersect? Well, if I graph this first one, y equals 1/2 x plus 4. Second one, I have to subtract x on both sides. And then divide by -2. I get y equals positive 1/2 x minus 5. So I plot the -5 and I go up 1 over 2. You're going to notice these lines, notice their slopes are the same. Their y-intercepts are different. These lines end up being parallel lines. So we say the solution, there's no solutions. So if two lines don't intersect, they have no solution. And what happens if the two equations end up representing the same line? If I solved each one of these out, I'm not going to take the time to do this. I'm just going to go right to it. So this will be y equals 1/4 x minus 2. And the bottom one, when I divide everything by -8, I'm going to get y equals 1/4 x minus 2. Slopes are still the same. The y-intercepts are also the same. When I graph those, I'm just basically graphing one line on top of the other, so we say there are infinite solutions. Okay? All right, so that takes us to the end of the video. If you have questions, let your teacher know.